It works a lot better if I turn on the microphone first. Technical difficulties, my bad. So today, we're going to be taking a look at this thing right here. 200 proofs the Earth is not a spinning ball. So this is by Eric Dubé. I happened to see it. Someone shared it on my Twitter feed. And you can find it at archive.org/details/200 proofs Earth is not a spinning ball _201710. So if you want to check that out, that should be very easy to find. It looks something like this. And I've gone ahead and downloaded the PDF version of it just so we can see it even easier here. As you can see, we've got a very nice cover page. Very nice indeed. Atlanteanconspiracy.com, ifers.boards.net. That's a nice, well done picture though. So I guess we're going to be talking about why he thinks the Earth is not a spinning ball. So let's dive right into it. I believe someone else has done a blog response to this as well, so I don't want to plagiarize anybody. Go to my notifications. Someone shared it to me. That's available at blog.daimonie.com on 2015-11. 20, I suppose? November 20th, 2015, yes. And you can see the details there. I'm going to have a few different points here, I believe. I haven't read all through this, but I've skimmed enough of it that I know I'm not going to make exactly the same points. So just to preempt any plagiarism, whatever stuff, no, I haven't really read his. I don't know what it says. I'm going to respond to it exactly as I see it here. And we're going to talk about why the Earth is or is not flat. Also, I got some really great apple juice right here. It's like actual apple juice. Not moonshine. Nope, not at all. Number 1. The proof for why the Earth is not a spinning ball. Alright. The horizon always appears perfectly flat 360 degrees around the observer regardless of altitude. Correct. Even if you look at a basketball, it appears flat. Right? You can see it looks like a circle. But if I hold up to you something that is, I don't know, for example, square, and I told you this was a cylinder, you wouldn't know whether it was or was not. I can diggle it around like that. For example, let's say I bring up a roll of tape. Okay, this is a roll of tape. But if I hold it like that, you're only going to see flat edges here and here, even though it's round. If we get closer to it, then you suddenly understand, even though it's round along this way, you can't actually see, the round part of it. All you see is a nice flat line, even though it's round. If I turn it this way, and I get sufficiently close enough, you can understand why it starts to look flat. Closer and closer until you can't actually tell that it's not flat, even though it's clearly round. So that's one way of explaining it. Staggerson Jag says, "Morning." I said, "Hello." What's up, Stags? Sucking Snacks Cock Like a Cuck says, "That's too long, man. You're just like 3 S's now." I was just saying to some black flurfers, flat earthers, I think, y'all beyond mongoloid, keep acting like y'all do, and the only thing you will prove that black lives don't matter that much after all. I don't think that's quite how it works, Mars. I don't think that's quite how it works at all. Unfortunately, that's not how it works. That's not logical. But you are flaming, so we know you're like a gay ally or something, so that's fine. Whatever. So yeah, if you look back here at the pictures he's got, then we got the we got all these views. Hey, remember that tape roll I was showing you here? Same idea. If the Earth is round, why don't you see? If this is round, why does it look flat? I don't know. I don't know. Why does the horizon appear that way, no matter which way I turn the roll of tape? You know? That's why it's flat. You're so close to the surface, you honestly can't see it. See this picture here? This picture right here is going to be useful in a minute. Because if you are at T, okay, right here, and you take... Mars says he will retract. All right. It's free speech. You can say whatever you want, but things like that are really just weird and kind of racist, I guess. But yeah, we're talking about flat Earth, not BLM. I don't want too many politics here. At least not on this one. So yeah, if you are standing where T is, any direction you look is going to look just as flat as this. Because you're on a sphere, you see. So what that means is, the further you get away from T, hello mole, you're going to have the tangent lines that run either direction down this way from wherever your eyeballs are. So this cross section where the tangent hits is still going to look flat to you. So if I have an actual little ball here, this is a sphere, even though you can't tell from the fact that it's a 2D projection on your screen, okay? No matter where you look at it, the edges don't appear to curve away from it, you see. And the closer you get, again, the closer you can see, less and less of the curve, but it's not really good to show it here. Because even if I hold it as close to the camera as I can, you're still talking about being further away than the ISS is, and the ISS can see that much of the sphere as well, you know. So, when you're on a sphere standing at any given point, where the point is the center where you are, then any tiny little fraction of it you take any direction is going to look at, you know, being flat. So when the two angles come together, and you've got one angle here, that's the only part you're actually seeing when your eyes are very small off the ground. You have another on that side, and the whole thing looks like a disc, because the line's going around it all the directions. So since we've got that basic one out of the way, because it's going to come up several more times, horse-wearing people costume says, do I look as a mole to you? Yes, you do. You have 4 legs, you have some hair, you have a long nose, you look very much like a mole. Horseman. So we go on to point number 2. The horizon always rises to the eye level of the observer as altitude is gained. Correct. That goes back to, as you go up off of the sphere, you know, your tangent is normally there. The further up you go, the more it turns. And you have one on the other side that's the same way. In effect, you have a triangle. And the vertices of those triangles tells you where that horizon is as you go further up. You know. So that one's very easy to discuss as well. It says if Earth were in fact a globe, no matter how large, as you ascended the horizon would stay fixed. No, it wouldn't. We just showed you with math. So that one is wrong. I just used very simple math with my fingers and a marker, and I showed you right where it was wrong. It says over 20 miles high, horizon is still 100% flat. Well, it's not 100% flat, you just can't perceive the curve. Because again, you're still statistically no further away from it than you were at ground level, as far as the horizon being flat or not. Because the Earth is very large. 20 miles over 16,000, which is, or 12,000, I guess, would be the diameter. 6,000 would be the radius. That's still a fraction of 1% elevation. So you're talking about seeing it at 179 and 95 hundredths of a degree rather than 180. It's not enough for you to notice a difference with your eyes. It'd be the same as if you turned your head sideways and said this eye can't see the curve and this eye can't either. And that means there is no curve. It's just simply not true that way. And Stag says, this is what my next vid is on curvature. So good, we're having a free primer here that Stags can just steal from. Maybe we can get Emmett on for that one. Emmett would be great to talk about the flat Earth with. That's just wrong. The horizon is never at eye level unless you lay on the ground. Well, that's true. But the horizon is at eye level based on where your eye creates a tangent with the Earth. But for our intents and purposes, being 6 foot off the ground is the same thing as having your head on the ground when the sphere has a radius of 12,000 miles or whatever. Horse says, does a mole taking Earth's curvature into account when navigating beneath the Earth's surface? No, it doesn't need to. There is no horizon underground if you can't see it, right? It's like an ostrich. You just dig your head in, you don't have to worry about anything. Horse says, hate crime, hate crime. Well, no, the mole can just dig away. It'll be alright. Speaking of which, mole disappeared very quickly. He's being awful quiet. 3. The natural physics of water is to find and maintain its level. That is correct. If the Earth were a giant sphere, and we can ignore those, then truly flat, consistently level surfaces would not exist here. That's, again, incorrect. A sphere, mathematically, doesn't actually have a curve. A sphere is an infinite set of points or very small line segments which roughly approximate a sphere. There's actually a mathematical proof you can use for this. We don't need to go into it. But it's how you arrive at pi, actually. You take and you say, well, if a circle was a square, for example, you start with a square, and then you put the smaller squares on the side of it that are half size, and then quarter, and eighth, 16th, and all that, all the way out. You can actually calculate the ratio of how many squares on a side will give you the curve of a circle, so to speak. Again, math isn't my strong suit, but that is a mathematical proof for it. Just saying, it's out there. You can see it on Numberphile's channel, I think. And then there's actually a second point there about the level. Well, you got to remember, if the Earth is a sphere, all right, and, you know, the surface is relatively uniform, and if this thing has so much gravity that nothing is going to escape it, for all intents and purposes, if that's the Earth, then the sun is about 16 miles that way, I think. I haven't done the math. And the moon is somewhere about 30 or 40 meters, whichever direction it is orbiting it. It's a quarter of the size. Maybe not that far. Again, I'm just approximating numbers to show the relative distances within an order of magnitude or so. If I put a drop on it of any kind of liquid, and it doesn't matter if it's spinning or not because the gravity isn't enough, the spin is not very fast. Okay? So what's happening is the water is going to kind of swirl around it for a while when it's spinning, but it's eventually going to coat the whole thing just as oil will coat a thing in water. So then what you've got is the gravity is the dominant driving force, and it causes it to evenly coat the sphere in the water, and then it finds its level, so to speak. You do still have tides because of the moon and because of the rotation, that sort of thing, and even because of the sun a little bit. But for the most part, water is going to stay level in any one given place because the water is moving at the same speed as the atmosphere and at the same speed as the planet, so those forces don't really affect it. Then we can simplify those by removing them for the model, and it will find its level, whatever it is, on top of that core. So again, that's a really long way of saying, flat or round, it doesn't matter, it's going to find its level. So we go up here to point 4. Rivers run down to sea level, and that's actually not true either. Here at about the 40th or 42nd parallel, I believe, there's actually a line where the rivers below it run toward the equator and above it run toward the North Pole. And in the south, I believe you have the same line, somewhere down around the southern part of Australia, I think, where most of the rivers are going to flow toward the South Pole when they're below it, and they're going to flow toward the equator when they're above it. So that's actually not true. It says if Earth were truly a spinning ball, then many of these rivers would be impossibly flowing uphill. Well, and again, gravity is a much more dominant force than the force of the Earth. But no, either way, the water still won't flow up an actual hill. It will flow where gravity tells it to, so to speak, because that's where the gravity is pulling on it. Just because it's pulling it down, let's say you have a hill, and at the top on either side there's a spring that comes down, in 4 directions, let's say. The water is always going to flow straight down, regardless of whether this side of my hand is the north and this side is the south, you see. But yeah, water always finds a low point. Mike says, there's actually waterfalls that go upstream. That is correct. I don't know where they are off the top of my head, but there are a few of them. There's actually also one down in South America that boils for some reason, even though a river of that size shouldn't, because it gets enough geothermal energy that the river literally comes out of the earth. And Larry says Earth is a rotating planet, not ball. I'm not sure what you mean there, but the Earth is roughly spherical. It's more spherical than this thing I'm holding. And it's pretty much just a sphere. It's actually more round and smoother than a cue ball that you use in a professional tournament, on average. Even if you take the highest point on Mount Everest and the lowest point on the Marianas Trench, that's still a smaller percentage of the overall diameter than a defect that you're allowed to have in a regulation cue ball. Just to put it in perspective, cue balls are very smooth, and the Earth is smoother along the surface. It's an oblate spheroid. Yeah, yes, just very slightly. So too is a basketball when it hits the ground, but it's still a sphere. It's still a ball. One portion of the Nile River flows for 1,000 miles with a fall of only 1 foot. That's fine. It can do that. I mean, it clearly does. Parts of the West African Congo, according to the supposed inclination and movement of the ball Earth, would be sometimes running uphill and sometimes down. Oh, I see what they're saying. No, they're saying if the North Pole is up, then all the rivers have to run away from it. No, gravity pulls equally here as it does here, or here, or here, or down, or left, or whatever. And it pulls equally towards me and away from me if the paper is the sphere. The gravity doesn't care where you are on it. This is not the top and this is not the bottom. When you're talking about the Earth, all of it is equal at that point. For anything that's not magnetic, essentially. So if you're talking about falling down, the rain doesn't start at the North Pole and flow to the South Pole and then fall off the bottom of the Earth, you see. A flat earther, on the other hand, believes the Earth is kind of like flat, like a thing, and then everything sits on top of it. That's not the best thing to use to show the flat Earth, but you get the idea. And so they believe everything is a sheet, the North Pole is at the center, and then they believe all the water runs out to the sides and then freezes to become Antarctica, whatever, or the Arctic, which I guess goes around the outside, but maybe sometimes is in the middle. I don't understand it. I want to see the thing they never tell us in this. Jags says his dick is an oblate spheroid. Well, that's unfortunate, Jags. I think they have surgery for that. I think. That can be cosmetically fixed if you really, really want it to be. But then again, maybe the ladies like it better. I don't know. I'm not a lady. I couldn't tell you. But basically, yeah, and this is the one thing the flat earthers never tell us, is which flat earth theory hypothesis do they actually believe? Do they believe, for example, that the North Pole is at the center and that the South Pole is everywhere along the outside? Or do they believe that some point arbitrarily on the Earth is the center, along the horizon or the equator, let's say, and then they believe that the North Pole takes up the top half of the circle and the South Pole takes up the bottom? Or do they accept some other version of it that I'm not familiar with? Maybe it's like a conveyor belt and it goes around on itself. Or maybe it's coin-shaped, or maybe it's oval, or maybe it's something else. But that's something they can never agree on, even though they're sure we're wrong. That's fine, they don't have to. But if they want to provide an explanation for why the globe can't exist, they have to show us which flat Earth is correct. Like, for example, I was watching once, a fella posted, and I bet I can find it really easily. We'll try that in a few minutes here. A video about, oh, what was it? It was like a nighttime flight. All right. And what he was saying was that, you know, no matter how far this plane went, the horizon was consistently flat. It was at nighttime. It was all this good stuff. And what that means is that somehow there is no curve to it. So hopefully I can find this again very easily here. And we'll demonstrate why that is wrong very simply. Not going to find it that easily though, am I? Of course I'm not. That was a while ago though. So anyway, when you're looking at, for example, a video of someone flying at night and the horizon does stay consistently flat and at about the same distance, all that tells you is you're only seeing that little portion of the sphere. So, for example, if I was going to take, again, one of these neat... Yeah, Larry says, I agree. Show me a working model of the flat Earth. And I'm going to demonstrate to you, again, if this little ball right here is the Earth, these little, these spheres are pretty neat, too, because they actually, you can't see it very well, but they glow a little bit. But if you are, for example, one person, and you're standing on a very tall building or a mountain or whatever, then the entire disk you're looking at is still smaller than that point that I just put on there. For comparison, if you're in an airplane, that's about how much of the Earth you can see in that little blue dot that I made. And that's why it all looks flat to you, because you can't see very much of it. So what that means is you're just not seeing very much of it. I don't know how else to put it, I guess. I am not going to find that video right now, and that's fine. I don't need to find that video right now. This would also be the case for Parana, Paraguay, and other long rivers. No, it wouldn't. We just demonstrated why. Again, the Earth doesn't care. That little blue dot, again, for example, is you. Even if you're up here at the top of it, or you're down here at the bottom of it, it doesn't care. You're always the center of focus. Because again, everything on the surface of the Earth is spinning at the same speed of it, you know. So you're the dot on the surface, right? You're moving with the surface. The surface and you are at the same speed. The same as the rest of the Earth, and roughly speaking, the atmosphere, although that's partially why we get winds. The other reason we get wind is because the Earth is unevenly heated. If I block out this light a little bit, you still can't tell. That's still not enough variance. But you can see one side is brighter and one side isn't. There, that's actually pretty good. That's why we have wind. Because this side is colder than the side over here, where the sun is hitting it directly. And so this side, the pressure increases, this side, the pressure decreases. And generally, that's why your winds always go the same direction the Earth spins. You see. And that's why your weather systems always generally move from the west to the east, because of the direction the Earth is spinning. Just a fun fact, you can't explain weather very well with a flat Earth. You can if you pick one model, but you can't do it well and then you drop everything else. So number 6 on the... This is going to be a long video, but again, a lot of these are going to start becoming repetitive very shortly, I believe. If Earth were a ball 25,000 miles in circumference, close enough. Alright, Mole, we'll see you in a few minutes. Thanks for tuning in case you get lost. You want a wrench? I might be able to do that. I think I can do that. Whew, pardon me. If Earth were a ball 25,000 miles in circumference, yes, as we have established, that's close enough. As NASA and modern astronomy claim, it's actually closer to 24,000, I believe. But, you know, whatever. Spherical trigonometry dictates the surface of all standing water must curve downward, an easily measurable 8 inches per mile, multiplied by the square of the distance. I believe what they're talking about is a meniscus, and the fact that we don't notice it as much, well, 8 inches per mile isn't very much, for one. For two, the meniscus of something that large has different variables that dictate it, because water is very dense. And the other thing is, the water on one side of the ocean doesn't immediately affect the other. Same with gravity affecting the tides. It doesn't happen uniformly all at once. There is the delay of the speed of gravity as well as the resistance of the water, the resistance of the land. The salinity of the water changes the meniscus too. And the salinity of the water is not consistent throughout the ocean. It's variable. Whereas in a lab setting, you can get pretty clean water, you can get consistently salty water in small, flasks, basically. But even so, 8 inches per mile isn't that much. And if the Earth curves outward, it can still pull the water kind of flat across that. And you're not going to notice it much when the ocean is as deep as it is. And the meniscus is going to be relative to the water itself rather than the masses of land that would normally confine it. But again, it's more complicated calculus there, which is why I'm not going to get into it any further. You can look it up. Again, I don't expect any of you to take my word on it. Staggerson says God did it. I think Emmett got on the keyboard there. Larry says, in a certain way, Stags. I'm a little slow to read comments if you haven't caught on. This means along a 6-mile channel of standing water? No. Because if your standing water is in a long river that just happens to be dammed up, then the meniscus is only going to go mostly along the narrow edge of it, which is the riverbanks. Because the long sides won't care as much. They'll find their level, and then it'll be canceled out because of the surface tension and that sort of thing, as well as the pressure of the water pushing up from below. The Earth would dip 6 feet on either end from the central peak. Again, I don't know what model they're talking about, so I can't say if that would even be true or not in the model they're discussing, because they're not. Oh my, we're having a lot of fun. Surveyors, engineers, and architects, for point 7, are never required to factor the supposed curvature of the Earth into their projects. Yes, they are. Surveyors especially have to rely on the fact that the Earth is round to determine that we get the correct angles for property lines or whatever. Because if you look at a sphere, and again, we'll get out my handy dandy spheroid right here. Like I say, these things are really cool. I think I originally saw them on Thunderfoot's channel. But if you put a blue laser to them, or you hold them under a fluorescent sight that has a lot of blue light to it, and you leave them there for just a little bit, these things will light up ever so slightly. Again, you can't necessarily... There we go. That's cool. Alright, yeah. They'll absorb some of that light and you'll have that. And they'll make just a faint blue glow, which is really neat. But getting back to what we were talking about, I can draw what we call a straight line. We can understand that. Now let's pretend I want to draw 2 more straight lines to make a triangle. And there's an interesting thing here. Those are about the right size. Let's try it. I don't like that one at all. So we want this one. We want this one. And we want, yeah, this one. Okay. And now, for example, I have a triangle on there that's comprised of 3 roughly straight lines. Well, the surveyors do today rely on GPS, which relies on relativistic effects that actually help us cancel out the sphere so that we don't have to worry about it as much. But for example, in old-fashioned surveying, when you wanted to make a map, you have 2 choices. You have that one, or you have this one. So what I done here was, and I still didn't get it perfect. Let's drag it up a little more. There we go. Those are a little straighter. Okay. So what I done here was, just so you can see it, I drew 2 right angles. They're basically right angles. They're as close as I can get without, a straight edge and all that crap. But on a sphere, those right angles will always come together to make a triangle somehow. You see. I can also use those right angles to make a square a little differently with a different kind of straight line. But you get the idea. On a flat Earth, I can't do that. Because you have a Euclidean versus a non-Euclidean form of mathematics. You see. Now, if this was a sphere, and I drew the 2 right angles, which are really hard to see there. There we go. Close enough, I guess. On the flat Earth, those are always going to be a square. On a round Earth, you can have the 2. I can even draw another straight line here that's even better. Because both of those lines are straight and they still meet each other. Again, I draw terribly, but it gets the point across. You can't have satellites to disprove flat Earth, says Larry. And he's right. Satellites wouldn't make any sense if you didn't have gravity working the way it does. I don't think they're going to bring that up in this, but they may. This was written perhaps before that. Well, no, it says this is recent, 2017-10. I'm guessing it means last month or this month. So anyway, you get the idea. Just with a very simple toy, you can show people that triangles on a sphere have more than 180 degrees. On a flat Earth, they don't. It says often hundreds of miles without any allowance for curvature. Right, if you're just drawing one of these segments to connect 2 cities, then you don't actually need more than 1 line. However, if you got all 3 cities, then you do have to take it into effect. So yeah, sometimes over the course of even 1,000 miles, the curvature doesn't matter because you're just going in a straight line. But sometimes it does. Flight patterns come to mind also. And that's why it's sometimes quicker to fly in a straight line that goes some other direction than where you think it should. Number 8. The Suez Canal connecting the Mediterranean with the Red Sea is 100 miles long without any locks, making the water an uninterrupted continuation of the two seas. Well, that's not true. It's a canal. It restricts the width of the seas. If we take a look here, I think is kind of the thing they're talking about. Here's an ocean, and here's an ocean. And they've got a composite photo here, but they're showing the thing in between it. The stuff that affects this large body of water does not affect the small body of water in the same way. And we know this from elementary physics, dealing with pressures and flows and other hydrological and hydrostatic systems. We understand that when you put a large thing and compress it into a small pipe, the physics of it change greatly. But we can come back to that later. Also, you got to remember it's a lot deeper and then a lot shallower, so there are literally two different bodies of water right where the delta meets, essentially. But again, we can always come back to that if we need to. When constructed, the Earth's supposed curvature was not taken into account. It was done along a horizontal datum line of 26 feet below sea level, passing through several lakes from one sea to another, with the datum line and water surface running perfectly parallel over the 100 miles. Well, no, not really. Again, it's going to curve with the Earth, but 100 miles still isn't a lot of curve. I'm not sure what it means perfectly parallel, but you can do that even if you know nothing about physics. I can pick a point here and a point here, and we have our 2 points. And I can connect them with a straight line, and I can go directly south of that line and connect it with the same kind of straight line. And I'll still have the two parallel lines for 100 miles. In fact, that's how latitude works. You have lines that go all the way around, perfectly straight lines, and that's how your latitude works, you see. So you got the one on top that's the poorly drawn circle. And then you have the circles that are concentric all the way around it when you look at them from this direction. But they're perfectly straight when you look at them this way, because that's how lines on a sphere work. When you get to longitude, on the other hand, you have a point at the top and I don't know, roughly where's the center of that point on the bottom. You draw the other kind of line, such that this comes around here, you turn it a little bit, this comes around here, and then you actually get your lines of, or I'm sorry, those would be longitude. The other ones are latitude. So what you get there is you get the poles represented as an easy way for humans to think about it. And you can draw that straight line anywhere around it you want to connect those 2 points. And you've basically got a two-sided object on a sphere. Looks like an eyeball. Stag says, for the record, I was already planning on using a marker on a ball for my video. I don't care. You can steal from me, dude. I ain't gonna get pissed off. You can just basically redo my whole video. It's not illegal. You just like can't stream my whole video without talking about it. That's basically the only thing. That's why response videos work, because we give our own original input and we don't use the other video as the majority of it. That's why I stop and talk about each point for so long. That way they can't possibly say it's not copyright infringement. And the fact that someone else responded to this, like, I'm not plagiarizing them. I don't even know what's in their article. But we're talking about the same points in the same order on the same article. We're probably going to have some overlap there. You know. But yeah, Stags is just stealing all my ideas. He just doesn't want us to know it. Nice. I don't care. Steal my video. What am I going to do about it? Mine aren't even monetized. You just give me more FaceTime. Go for it. Number 9. Engineer, this dude, was published in the Earth Review regarding the Earth's supposed curvature. The Earth Review. I wonder. Oh, there's no citation. Is there a citation at the end for point number 9? No. There's no citations. Alright, so let's pretend that he did say whatever he says. Number 1, I don't know what kind of article it is. So as an engineer of many years standing, well, man, take a seat. No wonder you're tired, you're cranky, you don't see things the right way. I saw that this absurd allowance is only permitted in school books. Maybe you're just a misguided fool, I don't know. Anecdotes are not evidence, so tell us what evidence you have. No engineer would dream of allowing anything of the kind. Of what kind? You're not very clear here. Earth Review. Let's see what that is. The Whole Earth Review? No, that doesn't make... Blue Earth Review? That's a Facebook group. Yeah, I don't have a clue. There's no citation. So, basically, this fellow's just giving an anecdote and saying he thinks it's wrong because reasons. So, we can actually just skip that one because no citation means I don't have to do any work either. The London and Northwestern Railway, for point 10, if I can speak today, forms a straight line 180 miles long between London and Liverpool. Nice. I already showed you how that can work, so we don't have to go back to that point. We already understand. Mike Nahernick says, hey, just playing Enderall as I listen to your stream. Sorry, I left the stream last night. I wanted to catch another stream. That's fine. It's all good, man. We have our own lives. We're allowed to do what we want. Sometimes games are more fun than talking about, Yeah, we talked about some fun stuff last night, though. That was kind of fun. Anecdotes for days. But yeah, alright. The London Railway runs on a straight line, yes? And as we said, so do latitude markers. They also run on straight lines, and they still meet in the same place. Longitude, my bad. Longitude goes up and down because it's longitude. Latitude's like fatitude, it goes around this way. I keep getting them mixed up, but you get the idea. The longitude marks the equators and where they are relative to one another. The latitude marks the equator. I said equators, didn't I? I meant poles. Whatever. I can't fucking speak today. It's fine. It's fine. It's fine. So number 11. A surveyor and engineer of 30 years published in the Birmingham Weekly Mercury stated... That sounds like a really old publication, doesn't it? Why didn't they just cite where it came from? Because they didn't cite where it came from. Okay, let's go of this. Incapable of any practical illustration. Yeah, I agree. You haven't given us one yet. All our locomotives are designed to run on what may be regarded as true levels or flats. Right, because when you account for gravity, you can treat it as level, and forget about the curve over short distances, like the length of a train, compared with the speed the train runs at. Now, if you want to send a rocket around the Earth, and you want the ISS to be accurate, moving 24,000 or 30,000 miles in 80 minutes, then you have a different kind of physics to deal with. Nathan Oakley 1980 says, good evening. Well, good evening, Nathan. It's afternoon here, so I presume you're on the other side of the pond. So good evening. Thank you for joining us on the other side of the big curve. All our locomotives are designed to run that way. We said that. Tree Hugger says, anybody have a phone number of a good-looking 18-year-old virgin who believes in flat Earth? I don't. Artemis might. I don't think that girl's 18, though. I don't think she's a virgin either. But anyway, no, I don't. But anything approaching to 8 inches in the mile increasing is the square of the distance. Which you don't understand, the distance becomes relative. Could not be worked by any engine that was ever yet constructed. So says this guy. Again, we don't have a proper citation. We don't actually have to deal with the rest of this point. But we've already dealt with all the points in the past 9, so that's fine. Nathan Oakley says, there are no photos of Earth from space. Yes, there are. Men have never been to the moon. Yes, we did. Research flat Earth. All right, Nathan, which flat Earth? Which flat earth shall I research? Because I've been trying, and I can't seem to find the one people tell me exists. There is no measurable curvature to the earth. Well, there actually is. I'm not sure if Nathan is a troll or not, but Stag says lol, and that's what I'm saying as well. But I am curious, if there is a flat earth model that you think works to explain everything, I suggest that you submit it, because we're 12 points in and I don't have it yet. Also, you're very lucky I'm only drinking apple juice cider, because I get worked up when I have the alcohols. Water at rest is measurably flat. No, water at rest has a meniscus and always finds its level. Usually. Unless you have like a Cartesian spring or something, then it finds the level of the pressure being applied to it. Water at rest does not bend. Well, that one's easy enough. I can just get a shot glass and I can put water in it and you can see the meniscus. It is there. Show some photos of Earth from space. Okay. NASA.gov. There's plenty. Do I really have to do this? Do you not understand how Google works? Alright. This thing right here, it's called Google. You can go to it. If you don't like it, you can go to Bing. You can go to DuckDuckGo. You can go to, NASA.gov. What else would you like me to bring up to show you the photos of Earth from space? Which search engine do you trust? I'll be glad to use it. But for now, I'm going to use NASA since they seem to have it. If you don't like that, I can get the guy who sent up the weather balloon. But let's take a look at the photos of Earth from space. Alright. Here we go. From the ISS, we have some missions. International Space Station. So, live Earth views from the station. Here we go. High definition Earth viewing system. So here we go. That's basically a live feed. Looks like fuckhead argues lie. Fuckhead must be a fuckhead. I don't know what that means. I presume that means what you said. Lane says lee-da-lee-da-lee. That sounds okay. But here you go. This is Earth, unless you say that it isn't Earth. You can see the clouds rolling towards us from the horizon. So there we go. Fish, he says. Why isn't there a moon or planet shaped like a fish? That's a good question. Probably because fish like pancakes. That's always the answer I was given. So Nathan Oakley says, show me a working globe model right here. It's on the screen. Can you see it? Unfortunately, flat earthers like myself have tested it against reality, and the globe is certainly not a working model of Earth. All right, Nathan, I shall ask you again. What is... It sure is awful loud, Al. What is a working model of Earth? By the way, if you think the flat one is correct, which flat one? All right, Nathan. If you don't believe that, then why do you accept that this shows a flat horizon when it's just a picture? This is just a picture, Nathan. How can you tell me that's a flat railway? Nathan, you clearly believe everything you see on the internet. These pictures are flat. Why do you believe them? They're just pictures on a screen, Nathan. Why do you accept them as truth? You are the one who asked for pictures and I gave them to you. Now, I'm going to ask you nicely one more time. What model do you use to describe the flat Earth, Nathan? All right, I see. That's fine. That's one way to do it. You can say whatever you want, Nathan, but I can also block you, or put you in timeout, rather. So in the 5 minutes you have, Please go ahead and show us what model of the flat Earth you use. I'm willing to look it over. Where are the North and South poles in relation to one another on it? Flatfish says, I challenge anyone to video themselves spinning without feeling any force. What would that have to do with anything, Fish? Why would spinning mean you're not on a ball? You've never seen the Harlem Globetrotters spin one ball on top of another? I'm curious. Have you actually never seen that? Spinning like what? Dick Cheney. I'm honestly not sure what Fish is talking about. Why a geostationary object would not feel force if it submitted force upon itself. I don't honestly understand what it would prove. No, Fish, tell me first what your prediction is about why the force I feel or the force I don't feel would prove that the Earth is flat. Please, explain that to me. Make your prediction before I do it. Can you do that, Fish? That's a negative, Ghost Rider. Moving on to point 13. In a 19th century French experiment by M.M. Biot and Arago, Rev JR, don't let these clowns derail you with their retarded questions. They're not dumb questions. They're just questions that they don't actually have answers to either. But I do. But the point is, they don't understand that asking questions isn't a valid response. When someone asks you why. Socrates is great, but you have to give me an example that shows yours works better than mine. Fish and Nathan. Now, when that 5 minutes is up, Nathan can present me with the model of the flat Earth that he says is better than the globe. A screen name, I can't fucking read. You think you are spinning 1,000 miles an hour on a ball? No. I am stationary relative to it, the same as you. The same as most of the atmosphere. Hurtling through infinite space, not infinite, we're only in part of it, at a gazillion miles per hour, no. We're only spinning relative to the sun at something like 1 degree a day. And our radius is 93 million miles. So definitely not a gazillion. That puts our orbit at around somewhere like 300 million miles. So we're going about 1 million miles a day, not a gazillion miles an hour. Flatfish says, globe model claims, you still didn't tell me what I asked for. Why would spinning in a circle on an object to which I am stationary cause me to understand the Earth is flat? I've done it before. Globe model claims you're on a spinning Earth and acceleration is constant. No, it isn't. It doesn't claim the acceleration is constant. We're actually slowing down slightly. Very, very so slightly. The acceleration is currently 0 when you are moving at the same speed as something. That's how acceleration works. When you are in your car, you and your car are stationary relative to each other. Even though the car is accelerating, you don't go 60 miles an hour into the seat right away. You speed up with the car. Then when you're moving at the same speed as the car, you understand why the air inside the car is not pelting you in the face at 60 miles an hour when you have a windscreen, right? So what you're saying is, Fish, if I'm standing on a train, in a train car, and I spin around, I should also feel torque because the train is moving? I'm trying to explain to you why this falls apart. Yes, it is. The tires on the car are spinning, so you're spinning around the tires. You don't seem to understand this. How can your car... Let's say you're on a unicycle, man. Torque is a product of spin, not motion. Fine, I'm on a unicycle. I am on the unicycle. I have one wheel. All right. I can stay upright on the unicycle, and once I'm moving at speed, what happens? I can do other things. Torque is a product of spin, not motion. So you're saying spin is not a kind of motion. Also, Fish, you haven't told me which model of the flat Earth do you accept. I don't have to explain it until you answer my question in response. Explain to me why spinning on a train proves that the train is not moving when the train is moving. Secondly, which model of the flat Earth do you subscribe to? Massive oceans stuck in a convex shape. No, we went over this. They're not stuck in anything, man. There are complex forces that describe how large bodies of water move. The fact that you want to disregard them just because you think it's a flat mass of water rather than a curved one is not my problem. Your problem doesn't go away just because your Earth is flat in your model. You understand this, right? Explain to me why the ocean doesn't have a dip if the Earth is flat. Why isn't there a meniscus if the Earth is flat? Please, explain that to me. Why that problem goes away as soon as the Earth isn't a curve. Also, to 3 of you now, which model of the flat Earth are you talking about? Remember, you haven't derailed me. I'm still asking you, because this is actually giving me plenty of good stuff to talk about. I'm not here to answer your questions. That's fine, then. That's nice. Then, I don't need to hear from you. You've been timed out. You can come back and tell me which model you believe in. Your problem is there are no real pics of your spinning ball. Yes, there are. Show me a picture of your flat Earth. You just told me the pictures don't matter, so why are you complaining there's no pictures? Now, can you kindly tell me which model of the flat Earth you subscribe to? I'm curious. Is the North Pole in the center? Is the North Pole at the top and the South Pole's at the bottom of a disk? Is it square-shaped? Is some arbitrary point the middle? And the North Pole goes around the outside and the South Pole's in the middle. We don't have a model. Okay, so you don't actually have a counter-argument. The burden of proof is on the outstanding claim, the globe, yes. That's why we're explaining it to you. Because you don't understand it, and you think that means that you have some other explanation. So what do you propose that eliminates the problems you're telling me about? I showed you pictures and you didn't want to see them. But now you're telling me you need the pictures that I showed you that you don't want to accept. Why should I accept your pictures showing me the Earth is flat? And Mike is correct, you do have the burden of proof. If you want to claim the Earth is flat, which is what you're saying, you have to demonstrate it. I am telling you the Earth is a globe, and I'm showing you why. Now you have to tell me which part of it I got wrong. You're not. You're asking me why does it happen, and I'm trying to explain it to you, and you're not understanding it. That's not my problem. It's your problem. Treehugger says, so I'll be back in a while. Happy way to spend a while talking to the other kinds of folks I rarely encounter. Swell. Someone is outside mowing. I do apologize if you can hear that. But, that's the way life goes in fall. So, let's go on to point number 13, since, a screen name says waste of energy. He is correct. He wasted his energy telling us that he believes in a flat Earth he doesn't actually believe in. So, yeah. Definite waste of energy. Please don't do that next time. Come to the table with an actual model. I realize you may actually just be a troll. I'm not sure. I meet a lot of trolls in my day-to-day life. So, whatever. Point 13. In a 19th century French experiment by M.M. Biot and Arago, a powerful lamp with good reflectors was placed on the summit of that place and able to be seen all the way, pardon me, from Campre on the island of Ibiza. Ibiza, I think. Since the elevation of the 2 points were identical, and the distance between covered nearly 100 miles, if Earth were a ball 25,000 miles in circumference, the light should have been more than 6,600 feet, a mile and a quarter below the line of sight. No, not if you're putting them on two very high points that elevates it just enough that you can see them. But, that doesn't explain anything, honestly. That doesn't solve your problem with a flat Earth, either. That's like asking, well, how can I see the light that's just a hair over the hill where I shouldn't be able to see it? Because the next thing you're going to tell me is that atmospheric lensing is a thing. But then you're going to tell me it doesn't work if the Earth is round, which is wrong because atmospheric doesn't work if the Earth is flat. But we'll come back to that later. But you can understand it simply by just looking at a piece of glass edge on. But you know. What is this Imperial they have? Silly Americans. I don't know, man. We have systems. So 14, another appeal to authority from I don't know where. That's another argument from anecdote. It doesn't really work. 15, if the Earth were truly a sphere, so big, and again, alright. Circumference of Earth. Alright. 24,901, almost 25,000. Fair enough. Airplane pilots would have to constantly correct their altitudes downwards. No, they don't. It just simply doesn't work that way because you're geostationary when you start off. Airplane pilots would have to constantly correct their altitudes downwards so as to not fly straight off into outer space. Incorrect, because the gravity pulls you down equally pretty much no matter where you're at over the Earth. So if you are constantly 30,000 feet from the center, from the surface, then gravity is going to have about the same effect on you all the place. And the speed of your acceleration is going to be described by a curve that looks kind of like this, which you're going to be constantly correcting anyway. An airplane does a lot of neat work, but also an airplane is floating on a foil of air that is a certain density because it is so far from the surface of the Earth, you see. So the airplane doesn't have much to do to stay roughly in that same density of air. And as the Earth curves, the density of the air is going to stay constant because of that. Also, if the plane were that large, it would stretch from, what is that, Florida to China? That's a big airplane. See these little dots here? Those are higher than most satellites. The arcs they describe over the Earth. Airplanes are much closer. 16. The experiment known as Airy's failure proved that the stars move relative to a stationary Earth. Oh, what? I feel like they're always making this stuff up. Airy's failure, let's take a look at it, was that to observe a particular star, he did not have to increase the tilt of his telescope when he filled it with water. What? That's, weird. I wonder, we could probably replicate that, but I'm not going to fill the Hubble telescope with water just to do it. By first filling a telescope with water to slow down the speed of light inside, nope, that's the first problem. The speed of light does not change just because you put it in water. The angle of incidence changes. The light still travels at the same speed. If it didn't travel at the same speed, then your light wouldn't become a prism, you see. Because then all of the colors would travel at the same speed and you'd still get a white ray of light, rather than one divided by colors, which refract at different angles. This seriously is basic physics Like we learned this stuff in 6th grade or earlier. And you can demonstrate these things. I can probably do it right here, and you can see along the edges some of the colors separating off or whatever. But I can't actually see that to confirm it because my glasses are off. Then calculating the tilt necessary to get the starlight directly down the tube. Okay. Airy failed to prove the heliocentric theory since the starlight was already coming in the correct angle with no change necessary, and instead proved the geocentric model correct. Which is really odd when you think about it, because now you've got to explain how everything else in the universe is moving so fast, and how the light all appears here at the exact same time, even though it's sped up and slowed down by the objects that should be spherical and have spherical atmospheres. Because if you want to explain gravitational lensing, or you want to explain like light going through the atmosphere of Venus, if the atmosphere of Venus isn't on a sphere, all right? Ignorance and failure to investigate is your only problem, Fish says. Time me out again, I'll eat your budgie. I don't know what the fuck a budgie is, but okay. Is that like a bodge? I don't know. Now this guy is talking gobbledygook, trying to convince himself. No, I'm asking you a question, all right? If the Earth is flat, does that mean all the other planets are flat as well? Let's take Venus, for example, and presume it is, flat like this bottle cap. It's flat for all intents and purposes. How does the light lens around the atmosphere that doesn't extend off the sides to make Venus appear bright on the opposite side? If Venus is flat like this, then why does it have an atmosphere on the bottom to lens all that light and make it appear almost as bright as a star? I mean, if Venus is a sphere, I can explain that very easily, because the atmosphere just goes around it. If it's flat, however, like a coin, if it's flat, right, then you don't get any of that. There is no atmosphere on the sides. Gosh, Flatfish, no science background, so sad. Flatfish says he's having a laugh, so I'm going to presume that means he's a troll, but I still answered the question. But you haven't answered me. Is Venus flat or not? I mean, I've got all the time in the world, and you still haven't told me which flat Earth is correct, so we can determine whether or not the Earth is actually flat, and compare your data to what is observed. Compare your predictions to what is preserved. 17 is Olber's paradox, and I don't know what that is. Flatfish says he probably taught our teachers. I doubt it. If you're telling me to eat my budgie, you're probably from another country where you understand what that means, because I don't. States that if there were billions of stars, which are suns, the night sky would be filled completely with light. Again, that's not Olber's... I mean, yeah, that is Olber's paradox, but we've explained that in the time since Olber died. Because the way light works just simply isn't the way you think it works based on Newtonian physics. I'm sorry, but it isn't. I'm also curious about Flatfish's science background there. Not that it matters, Flatfish just has to present his points. But, his business and ours. That doesn't mean anything. That's just philosophical waffling. I have an Associates of Science in, like, wind and solar and stuff. So, I have a basic understanding of science, is what I'm saying. In fact, Olber's paradox is no more a paradox than George Airy's experiment was a failure. Both are actually excellent refutations of the heliocentric spinning ball model. No, they're not. again, we don't have to go over it because we're talking flat Earth here. So, you know. Number 18, the Michelson-Morley and Sagnac experiments attempted to measure the change in the speed of light. Again, the speed of light doesn't really change, due to Earth's assumed motion through space. No, you're talking about redshift and blue shift and why we mostly observe redshift. That's because the fabric of time and space is expanding, as we now are able to predict. Keep laughing, Flatfish. It's all you've got so far, I guess. Now, do you want to tell us which model of the flat Earth to look into? I'm getting tired of asking. You don't actually have one, so you can't say the Earth is flat. The Earth could be a cube. The Earth could be a cylinder. You don't actually know. But we do. That's why we're trying to educate you. Tell me why the Earth can't be a cube, Fish. After measuring in every possible different direction in various locations, they failed to detect any significant change whatsoever. Again, proving this stationary geocentric model. Not really, no. It just proves you don't understand relativistic science. Here's a graphic of it. Carried out a simple experiment passing light in opposite directions around a table and recombining them. The fringes changed. This doesn't... Yeah, I mean, whatever. It doesn't really tell us anything about anything. Tycho Brahe, famous dick, famously agreed he died by eating himself to death. Against the heliocentric theory in his time. Right, a lot of people did. That doesn't make them right. Positing that if the Earth revolved around the Sun, which it does, the change in relative position of the stars after 6 months' motion could not fail to be seen. And for the most part, it's not. Relative to the Sun, we see them change. Relative to the Earth, we don't see as much change, but we can still measure it, because we have new tools. He can argue whatever he wants, but it's his evidence for it is what we're interested in. The guy had to look up Earth's circumference on Google, and he's here defending his precious ball. This guy got the number off. The guy got it off here by 100 miles. So you're defending this guy, who also didn't look it up. Neat. I looked it up just to be sure, because that's what you're supposed to do when you're a skeptic. You look things up, and you think about them. You don't assume that you just know the number. But unlike me, you're just assuming that you're correct and not worrying about what any of the papers say. That's true, says Flatfish. I have nothing to defend. So the Earth isn't flat. You're not defending that. Good to know. Please just repeat that every time you want to tell me the Earth is flat. You have nothing to defend. You made no claims. Oh, really? So, that's interesting. No claims at all. You say I'm talking gobbledygook. That's not a claim? Good. I'm glad to know that I'm not actually doing that. So I am approved by Flatfish as speaking the truth, because he is not defending the opposite claim. Thank you, Flatfish, for saying it directly. I could just go look at the video because this is all being recorded. "100 miles low." That's fine. You're the one that said I had to look it up. But you also wouldn't have known it if I didn't look it up. But anyway, you said I'm talking the truth, so it's fine. Why are you arguing with me if you have nothing to defend? 20. If the Earth were truly constantly spinning eastwards... Sure. Although we're spinning westwards, because, you know, the sun goes... Anyway. At over 1,000 miles an hour, vertically fired cannonballs and other projectiles should fall significantly due west. No, because they're already geostationary. The things on the surface of the planet are not spinning relative to the planet. You see, my cup and I are moving at the same speed. So if I let go of it, it just goes straight down toward the Earth. It doesn't fly 1,000 miles an hour that direction. In the same way that when I'm in a car and I go to reach for my gearbox shifter, I don't have to reach 60 miles an hour to hit it. Why can't I see Polaris from Australia, Fish? Larry wants to know. That's another good question. It's probably because Fish is a Poe, just like the other two. I mean, he did say I'm talking the truth, and he has nothing to defend. So I guess we'll let him off on that. Look up measuring the fractal length of an island. What will that tell me about the flatness of the Earth? Oh, somebody done broke the law. That was a police siren. Neat. All these noises. If the Earth were truly constantly spinning eastwards at over 1,000 miles an hour, you got to remember, the atmosphere is staying with it. You notice how there's not 1,000-mile-an-hour winds right now? How do you explain that even if the Earth is flat? How do you explain things going around it if the Earth actually doesn't have as much gravity as you think it does? Why would anything be locked to Earth if it's not spinning at all and it has no gravity? Why would it be locked to us? Realistically, we would be the very light object at that point. Gravity. Gravity, gravity. Gravity, gravity. I don't think he gets the gravity of the situation. But remember, he's not trying to defend the point that I'm wrong. He just keeps bringing it up for the fun of it, I guess. Even though he doesn't think I am, because that's not the point he's defending. Trolls are fun. Again, I don't know if you're a troll or not, but you're acting like one, Fish. So this is the best I can do. If Earth were truly constantly spinning eastwards at over 1,000 miles an hour, and again, it is, and so is everything else on it. Just like a car moving at 60 miles an hour, when you're in it, it isn't moving relative to you. Mike says, who made that clip? Rev? Which clip? Oh, the background clip I'm using? I think there's a link to it down in the description if the defaults went correctly. No copyright motion graphics or something. Yeah, if the defaults went correctly, if YouTube is still working right, the link should be down there to that channel somewhere. And if it's not, then I'll find it and add it as soon as this is over. We're almost a quarter of the way through here, so if the Earth is really spinning at 1,000 miles an hour, during the Red Bull Stratosphere dive, Felix should have landed 2,500 miles west. No. Again, the atmosphere is spinning with the Earth, in the same way that the bolts in a car travel with the car. If I take something and put it to the roof of my car and drop it, it's going to land in my lap, regardless of the fact that I'm moving 60 miles an hour, because the air in my car is moving with me. The car doesn't have to be spinning. The car is experiencing torque. Again, relative to the wheels, the car is going many RPMs. If you don't understand that, then I cannot help you. This argument right here, okay? It's saying that the surface of the Earth is moving 1,000 miles an hour. So I actually can relate it to a car moving 60. Because it's not talking about the torque of it. You realize that it's talking about just the simple, straightforward motion of it, Fish. If it were talking about the torque, you might be talking about the tectonic motion of the Earth, but you're not. If my car is spinning and I drop a ball, it will fly out the window. All right. So if I'm in a helicopter and the blades are spinning, and I drop the ball will not fall in my lap, is what you're saying. You're telling me you can't have a gyroscopically stable gyroscope on a helicopter because the rotors are spinning. And Obscure says the gravity quote clip is desert file. Actually, still, Fish, again, it works that way only if you do not have a closed system. According to you, if I am on a motorcycle and the wheels are spinning forward and I drop a ball on the wheels, the ball should be accelerated in front of me at 60 miles an hour. No, I'm not, Fish. You just don't understand how surface momentum works. And why the fact that the air moves at the same speed of us has something to do with the same thing as a cabin pressure in an airplane not going at the speed of the airplane through the cabin. It's not changing the argument at all, and I can't help it that you don't understand that it's the same argument. This is why the Earth flying through space doesn't have the atmosphere ripping off, because the atmosphere is moving with the Earth. The same as the air inside of a car is moving with a car. The vacuum doesn't provide resistance to slow down the atmosphere that we have. In the same way that the shell of a car keeps the air pressure inside the car from greatly reducing as when the windows are open. Because when you're in a car, if you open the windows, there's also an outside atmosphere that will act on the inside atmosphere. The vacuum of space doesn't have an atmosphere, Fish. So the atmosphere of Earth doesn't rub against it. Do you understand? Tie a car to a tree, drive around it really fast, and cut the rope. No, you're missing the point, Fish. The ground is still not a vacuum that you're driving on. And the Earth has gravity and friction that you are driving on. In space, you do not have those, Fish. That stuff that surrounds Earth that isn't the atmosphere. It's not like the ground that your tires interact with. It's a vacuum. It's not like the atmosphere that drops the pressure in your car and causes the wind to come in. There is none of that in outer space, Fish. If you want to cut that rope in outer space, you'd have to put a giant rocket thruster on one side of the Earth and then light it to give the Earth something to push against. Oh, I'm bothering Mole because this is fun. This is the best kind of fun. I can see the gears turning, but unfortunately he thinks there's nothing for them to turn against, so his brain isn't creating all the smoke that it should. You know. But these are actually not bad questions, they're just presented very poorly. And I still don't know which flat Earth somehow disproves the globe Earth. But as he said, you know, he's not actually trying to defend anything here. That's fine. I am. 23, ball believers. I like that. Hashtag ball believers. Let's make that trend on Twitter. Ball believers. And so we're going to call all the flat earthers ball busters. Alright? Ball busters. Hashtag ball busters. Hashtag ball busters. That's going to be the new tag when we talk about flat earth. They're ball busters. Claim gravity magically and inexplicably drags the entire lower atmosphere of the Earth in perfect synchronization. Not perfect, no. You have hot and cold spots. It's not perfect. But there's nothing on the outside of it to rub against it. It's a very gradual change. And the force of gravity, roughly holding it in place, is stronger than even the solar winds that would rip it away. You see, when you get out here, there's next to nothing, and the further you go, the less there is, until it's almost a perfect vacuum. And that's why nothing rubs against it. Again, this is basic science. We don't have to go any much deeper than that. Again, there is no ground the Earth is driving upon. There is no atmosphere in space that our atmosphere is rubbing against to cause pressure drops, to cause the 1,000-mile-an-hour winds. The Earth is very much like a car, in that the air on the surface is much like the air inside of a car. That's why sometimes you hit a bird who is in the atmosphere outside of your car, who cannot escape the ripple in the atmosphere that's being created by your car. It's also why some people who hike beside trains get sucked up against the trains, because it's not a vacuum. There's actual atmosphere outside of the train, you see. Number 24. If Earth and its atmosphere were constantly spinning eastward, and they are together, so they have a net acceleration of 0, effectively, apart from what the sun gives it from the heating of it. Flatfish says, so let me see your claim. Space experiences inertia, but not torque. Your sentence doesn't make any sense. Please reform it. I do not understand it. Then north-south facing cannons should establish a control. You're talking about the Coriolis effect here, number 24, and it's simply wrong. The Coriolis effect works because there's atmosphere around things. And when things move through the atmosphere, they do things. But yeah, space is basically a vacuum. It doesn't make any sense what you're saying. There is inertia, and there is torque, but, I mean, not generally on a vacuum unless you're talking about, like, I forget what it's called. Vacuum pressure, whatever. But even then, the little bit of it you're going to have, if you suspend something magnetically in a vacuum tube, let's say, a little piece of iron, you've got it to levitate because it's a superconductor, and you spin the tube around it, the thing will stay in place as long as you don't bump the edges, because the vacuum will not spin the object. Science currently allows for inertia in all space propulsion. Right, that has nothing to do with space. But you say torque doesn't apply. I didn't say that. I said that torque is a form of motion. You just choose not to hear me. I'm telling you torque doesn't apply when you're talking about the speed of the surface of the Earth, because the Earth's surface is large enough that the torque it generates is not enough to cause you to experience any significant effects of it. Inertia doesn't need an opposing force. Torque does. That too. And what you're trying to tell me is that cannonballs magically have their own torque relative to, like, the atmosphere. Again, I can stand a pen upright, and if I get it to stay there, it will stay there, right? I can take a thing, I can take another thing, and even though they're both moving at the same speed, it'll stand upright. Even though we're moving at 1,000 miles an hour, we're moving that speed together. So if I take and I pop it up and down, it goes straight up and down. If I drop it, it just goes straight down because it's moving at the same speed as my hand, which happens to be moving at the same speed as the ground. Yes, but you believe in gravity, yes, so where's the torque? Again, you are asking a malformed question. Gravity is not a torque-based force. I mean, now I know where the expression torqued off came from. You should also check out Abe's channel if you like getting torqued off. Because Abe is great with all his tool reviews. He's the best Canadian. Well, almost the best Canadian. Justin Trudeau is like the worst Canadian, but we're not talking politics, so let's, if Earth and its atmosphere were constantly spinning, again, we're just repeating the same thing over and over, literally. The same question is like 1, 2, 3, 4, 5, 6 maybe of these questions. Quoting Heaven and Earth by Gabriel Henriette, if flying had been invented at the time of Copernicus, birds fly, so it's been around for a long-ass time. Next question. 27. If Earth were constantly spinning, okay, yeah, same thing. Same question. Same question. 29, 30. In his book, South Sea Voyages, James Clark describes his experience on the night of November 27, 1839, and his conclusion that the Earth must be motionless. 200 years ago almost. And he might have thought that, or that might be out of context. I don't have that book, and at this point I don't care. Hey, take a look at this horizon that's not flat at all. The horizon starts here, and it goes down here, then it's kind of there, and then it goes up again. The Earth is a valley. The Earth is a valley. You can't claim inertia and gravity exist without torque. Nobody's doing that. We're telling you why they describe different phenomena within the same system of physics, and why one doesn't disprove the other. You can't claim that the Earth is torquing the atmosphere if there's not some outside force outside of the atmosphere which will torque it also. You see, the Earth may be spinning, right? Okay? And the atmosphere is going with it. So you have to show me what's out here, right? What's out here that's causing the atmosphere to run counter to it? Nothing. There's not. There's a vacuum. So the thing stays with it. It doesn't get torqued and go like this because of space. Space is a vacuum. Again, I don't understand what you are asking, so I cannot answer you. Rephrase your question. What do you think would cause the atmosphere to torque in this case? Like when you torque a bolt, you have three forces, okay? When you put a bolt in a hole, you've got the hole, you got the bolt, and you got the wrench, which you're going to use to wrench on it. Okay, so the bolt is like the Earth. I do get your point. That's why I'm asking you. Okay, the bolt is like the atmosphere. The hole is like the Earth. And you're telling me space is like the wrench that is torquing the atmosphere. But I'm telling you a vacuum doesn't do that. I do understand your point. I'm trying to explain to you why it's wrong. And you're not understanding what I'm explaining to you. I've never mentioned the atmosphere once. This guy did. Right. But you keep asking me. You asked me right up here. Tie a car to a tree, drive around it really fast, and cut the rope. Is there torque or not associated with this spin? There was when the car was tied to it. Correct. Gravity hasn't been broken. There's no ground in outer space for the car to torque against. There's no force there that would cause the chain to break. So again, I'm saying you're asking a malformed question. Because in this example, you've got the car, you've got the tree, and you've got the ground is the wrench. Okay? I'll put that thing so you can see it. So if these two are constantly together at the same speed, and the only thing changing is the ground causes it to do this, do you understand what I'm saying yet? I'm not sure if I can explain it any clearly to you. Right, inertia. From what? The inertia by itself doesn't do it. It has the inertia the entire time it's going around the tree. It's just constantly spinning. Same as Earth going around the sun. So when you're here in the center and you're going around it, if you break the gravitational bond, which you're not going to do unless the sun just disappears or something, your Earth still has something it has to torque against. And it's an entire vacuum out here. There's nothing it's going to torque against. Like, my hand doesn't exist. You understand this? I'm using this as an example. Gravity keeps it tied there. You're not going to break the gravitational bond unless one of the two bodies disappears. There is no my hand, which is just going to do this with it. There is no force, like a Hot Wheels, where it's just going to glide along an imaginary ground. Gravity isn't just simply going to disappear in this example. So again, I don't understand what you're asking. It's not the same question. The Earth is not driving on the ground, and gravity doesn't work like a chain like that. It's just a handy way of explaining it. There's nothing for the wheels of the Earth to torque against that is commensurate to the ground to cause it to go in one direction, as opposed to just continuing its gravitational lock. You see. So point 32. If gravity is credited with being a force strong enough to hold the world's oceans, buildings, people, and atmosphere stuck to the surface of a rapidly spinning ball, again, that's greatly oversimplified, but it's correct, then it is impossible for gravity to also simultaneously be weak enough to allow little birds, bugs, and planes to take off and travel freely, unabated in any direction. That's incorrect again, because gravity is a weaker force than the other forces of physics. That's why helium rises, because the gravity that pulls it down isn't as strong as the repulsive force that pushes it away because of its buoyancy, or its vacuum that it creates between its particles. The electromagnetic force wins. And because of this, the gases expand and the hydrogen wants to move up. The gravity still keeps it from just flying off into space. Once those two hit equilibrium, then the gravity and the electromagnetic forces, which are very tiny, cancel out, and it finds its level, so to speak, in the hierarchy of densities. This is why an oil will float on top of a water. Even though gravity pulls them both down, the water is a heavier molecule. It's denser, so it goes down. If you put a piece of lead at the top of that, it will continue to go through it, because gravity pulls harder on denser objects. Same thing. So the birds, to get over this, cause themselves to create a hydrofoil, which creates enough pressure under their wings to offset the weight of their body. And they go up because the pressure above their wings, when they're pushing down, becomes less, and they rise. There's work involved to do it. A bird that is not trying to fly falls. And that also doesn't say why it wouldn't happen on a flat Earth. Fish says, try rolling a hollow ball and a solid ball down a slope. They have different inertia and different torque. Right. Take away the slope is how the Earth works. Therefore, the mass of the Earth spinning is why there is torque, no vacuum required. Same experiment can be done in a vacuum with identical results. Removing the hill. Drop them in a vacuum and see if they fall at the same speed. And they will. Because now there is no friction. You see. One of them may spin longer simply because it has more mass, and it requires more energy to get it up to the same speed. But this still doesn't explain to me why that can't happen on a flat Earth. Why a flat Earth can't spin like a record. You haven't explained this. again, I don't have a specific flat Earth that you can show me and say this is why it is. That's why I cannot tell you any better than I can tell you currently. Right, if you have the hill, then you have a third force for the circle to torque against. If I roll this ball down there, oops, and it rolls, right? It goes down, It's now torquing against my hand. Okay. It torques against my hand because of gravity, 3 forces. If I drop it, it doesn't torque against anything, because there is no third force to cause the surface to go faster than the center. But there is inertia showing why this space vacuum is BS. No, there isn't. The atmosphere of the Earth is not rolling against an invisible hill as it goes around the sun. Negatorx wants to know, how does that show it's BS? But yeah, what I'm saying is, as it rolls down a hill, it has the third force, the same as the car on the flat plane. If you take those away, the thing just goes. And it can spin whichever direction it wants. It just so happens that the gravitational lock that the sun is slowly putting it into causes it to spin along the axis that it rotates around the sun, or revolves, rather than rotating in another one. Some of the bigger gas giants haven't quite got there yet, so they spin in a different direction altogether, because the gravity doesn't tidally lock them to spin the same way when they're further out, or they have a tinier core, or a denser core. But that's more the science than we need here. Again, remember, the Earth isn't driving around on a plane like this. The Earth is just spinning, and it happens to be turning because of the way gravity works on it and other things. The moon helps with that too, in regulating it, because it's not like a string. We just explain it that way because it's simple to understand. A better way to explain it, and I'm just going to play this video here if I find it. Let's take a look on, was it Lycra spandex? Okay. And you can't see this. You can't hear it because I don't have my speakers on. Oh wait, I do have the speakers on, but we're not going to listen to it through the microphone. So we're going to take a look at this fella right here. You all can see that. He's got a, good, that's close enough. He's got a sheet of spandex here. Alright? And you can find this video, type gravity spandex, just like I did there. And he's going to show you here, this is kind of how gravity works. This is a better explanation of it than the rope around a tree or the swinging something over your head example. And he's going on here in a bit. And he shows you what happens if you have, let's say, the sun at the center of it. And again, you can set up this experiment relatively inexpensively. The closer it gets, the quicker you can see it moves toward it, when they're equal size masses. And if they happen to be there, then you'll see the same thing happen, but you'll perceive both of them moving together, rather than just one of them moving, which is really what's happening in space. The sun is not stationary. They're both moving, but we use one as a reference point. So in reality, that big weight he just shoved in the center is still working just like the two weights when they were apart from each other. And that explains how your comets kind of work. You see it starts slowly when it's very far away, and then starts to get pulled in much quicker, as he's talking about. So all of this together combines, you'll see. For example, why does everything happen to go the same direction, or generally happens to go the same direction, around the sun? And in outer space, it's going to be like this. You're going to have this random nature to it. This is why most of your orbits are elliptical, just like the Earth. By the way, this is a great video. We're not going to watch the whole thing. And this is a very simplified way of explaining it. In reality, the sheet does not exist. It doesn't give the marbles something to torque against. Independent. It's not actually what causes the surface to spin in the way he's doing it. Because you got to remember, the sheet goes in every direction. Effectively. So if we skip ahead here a little bit, even if you take and you throw them in every which direction, for the most part, they're all going to eventually end up going the same direction because that's how it works. And thanks to Negatorx and Nick L for tuning in there and giving some feedback. So again, I'm not trying to be mean here. I'm just trying to explain it in the best way that I understand it. So we can see when you have two of them together there, as he's doing, and you should be able to see that, sometimes you'll get them to land in a stable orbit where one goes around the other. It's very difficult to demonstrate right there. So if you have two of these together, like a binary star system or whatever, you'll see how they also work a little differently here. You didn't quite get enough there, but, you know, the idea remains. This is kind of how gravity works. It's not exactly correct, but it's a much closer approximation to thinking about it than thinking about it as a string tied to something. You see. And again, the sheet doesn't really exist. So there's no sheet torquing the atmosphere and causing the atmosphere to spin like this around it. The atmosphere stays geostationary. Chris says, funny video because everything falls into the sun, so obviously Earth is going to fall into the sun. And yes, someday that will happen. But before that happens, because of the relatively stable elliptical orbit that we're in, the sun is actually going to expand to many times its size and swallow us up before we fall into it. Chris, the circular motion of the Earth around the sun provides an outward acting force which opposes the gravitational force of attraction between the sun and Earth. That's also pretty much correct. Again, it's not like a torquing force. It's like a it's just the acceleration force, the inertial force of it hasn't overcome gravity yet. I'm not explaining why I believe in gravity. I'm explaining how gravity appears to work. If you want to believe that that's a belief, that's your belief to have. Negatorx says, are you trolling? And I'm curious. If you think gravity is untrue, you can explain to me why things fall. But I'm curious to hear about it. If the Earth is flat and there is no gravity, why doesn't that just keep going up? Why does it come back down to me every time? Why? If you don't believe gravity works. Do I think flat earthers do not understand your reasoning and don't agree with it? Flat earthers do not seem to understand the reasoning. That's why I've been here debating with them. Flat says, sorry you dropped out before. Gravity, it is a belief. No, it isn't. I can demonstrate it. It works pretty much every time. It worked again. It worked again. I haven't fallen off of my chair up into the sky yet. So, no, it's a name for stuff that is observed. That's closer to correct, I guess. It is an actual force that works. Back to point 33. If gravity is credited with being a force strong enough to curve the massive expanse of oceans around a globular Earth, it would be impossible for fish and other creatures to swim through such forcefully held water. No. Fish are generally a little bit denser than water. As such, they can move through it. Easier some cases than we can move through the air. And we are much denser than air. Gravity is not a strong force. Gravity is the weakest of the forces. Therefore, it takes the most time to react. Therefore, larger objects are affected more by it, and smaller objects are affected less. A fish is much smaller than the ocean, but any given part of the ocean is also much smaller than the ocean. Flatfish says, so what is the name of the magical force that allowed torque to be experienced on Earth? You mean, what is the force that allows me to push a wrench against a bolt? Gravity. No, gravity isn't the force that allows us to torque things. Gravity is just a force that describes an interaction between objects. Gravity. So is there gravity in space? There is very little gravity in space because there's very little mass in space. The two positively correlate. If you have very little mass, then you have very little gravity. And if so, why not torque? Torque is there. But the tiny little bits of particles that happen to rub against each other once in a while are not the same kind of force as the spinning of the Earth. What's the specific issue, Flatfish? I am also confused. How about talking about angular momentum and linear momentum instead of torque? I mean, that's fair, but torque is a composite of the two, I guess. So I'm trying to keep it in terms that we can understand here and remain consistent without defining ourselves to death. Because angular momentum, when you place it against a wrench, does create, linear momentum and inertia and that sort of thing. So in the interest of not confusing it for the people that may not understand it, yes, you could talk about the complex calculus of it, but I think it's more useful to explain that forces have to have opposite forces. While I'm at it, talk about the moment of inertia. Yeah, that's fair. I shouldn't glaze over that so easily. But I'm trying to talk about the flat Earth, not why the atmosphere doesn't get ripped off by space. Even if everything revolves around us, that means the space outside of us also revolves around us. So, the rules of the universe are simple. An atom's position in a system is based upon its density in relation to the surrounding densities. And the changes in magnetism, electricity, and temperature, more or less, I guess. Density is the most important function in determining the position of an object. Not really. Density is the vibration intensity within a volume in relation to the density of the surrounding medium. Kinda, but when you talk about that, you're removing gravity from it. Kinda. While you're at it, talk about moment of inertia. Yeah, it's fine. Density is not a force. That's correct. It is explained by other, more complex forces. Newton's first law of motion, objects will remain at rest or continue at uniform motion until they're acted upon. Correct. Density is quite simply mass per unit volume. Correct. You can explain it based upon how hot or cold something is, too. That will change its density, but that's what they're driving at, I think. So why do things fall? They are more dense in the medium they exist in. Right, Chris. So what force pulls on them, Chris? Why do denser objects fall if gravity doesn't exist and doesn't explain why the denser things fall? Even on a flat Earth, if a denser thing is pulled towards the denser thing below it, the Earth, the center of the Earth, that's still gravity, Chris. So even if the Earth is flat, the fact that this ball falls still has to do with the fact that gravity is pulling on it because the center of the Earth is denser. Even if your Earth is flat. Otherwise, if your Earth is not as dense, then it's not going to fall to the bottom of the ocean. But I digress. All objects fall at the speed of gravity on Earth. Density differences do not reproduce this figure. Basically, yeah, if something is denser, it will fall slower. But that has more to do with resistance and friction and that kind of thing. But in a vacuum. There is no force pulling. What do you mean? There is no force pulling, Chris. You just told me those things get pulled down because they're denser. Now you're telling me they don't get pulled down because they're denser. But anyway, let's get back to the points, since that's what I was trying to do, I guess. I don't even know how many people are watching this right now. I should probably check that kind of stuff. Oh, look at that. We got a few people here. There's 11 hours of view time, and I've only been going for an hour, so that's kind of neat. Peak concurrent is 9. Analytics, we've got some chat rate and 44 playback, so that's kind of neat. People seem to enjoy this whether they agree with me or not. That's fine. You don't have to agree with me. I'm just here to present my points. We've got a great thing going on in the comments here. I like it. If density caused a denser object would fall faster. That is pretty much correct, though. If you drop something into a container of oil, it's going to fall slower because it's, oil is denser than air. That's fair to say. That doesn't change how gravity works. Because you're talking about, standard temperature and pressure and that kind of thing. And anyway, point number 34. Ship captains in navigating great distances at sea never need to factor the curvature of the Earth into their calculations. That's wrong. Sextants rely on the curvature of the Earth and which stars you can see and that sort of thing. And modern ships are run with GPS, which is based on a curved Earth and relativistic effects of the time difference between where you are and how triangles work based on the satellites and the time it takes to get to you and all that. But, no gravity, they get pulled down because of density, Chris says. Right, but why? Why does something that's more dense go toward the bottom instead of toward the top or toward the side? Chris. Not because of a magical force that no one can show or prove. Okay, so what causes the denser objects to go down instead of some other direction, Chris? If there is no gravity, why are there dense objects in the first place? I'm curious, honestly. So we can go right on to point 35. If the Earth were truly a globe, then every line of latitude south of the equator would have to measure a gradually smaller and smaller circumference the farther south traveled. That's correct. It does work that way. I showed it earlier in the video. But we can pretend, for example, latitudes just cut planes. They do measure smaller and smaller things. Sextants do accommodate for where the stars are based on the time of the year and where you're at relative to other land masses and things. They actually do use spherical geometry. I'll pull up a video later, for Pete's sake. But latitude works, again, kind of like this. You got a point. We'll call that the pole, let's say. And you got your first line of latitude that goes around it. I can't even draw. Second line goes around it. Third line goes around it. And fourth line goes around it. And so on. And I can't draw very well. But, if you draw a straight line around it, which I can't do very well while I'm holding it, you actually do get lines of different length just based on the fact of how this works. So yes, they do, in fact. Point 35 doesn't understand this. Now, when you get to the longitude, they just go from top to bottom any way you go around it, and you still draw a straight line. And the lines of latitude are all straight, but they meet at common points on the top and bottom. And they measure exactly the same length, because they all go through equators. You see. Latitudes do not. Chris says, why do you need a force pulling things down? How are things being pulled down if there's not a force, Chris? How do things have a density if you have no way of measuring it? How do you propose we measure the density of something without forces? How do scales work if denser things aren't being if they aren't exerting a force against the scale, Chris. If there's no force pulling it down, how does a heavier object, a denser object, displace water as it moves through it? Wouldn't the force of the water just keep it on top? Wouldn't the force of everything just stay even if there were no forces acting on it? Again, this model of the flat Earth says that the North Pole is at the center and the South Pole is around every single edge. In fact, I believe this standard map of the world was designed as a troll, but, But yeah, 35, we've already shown that they do account for different lengths. Even if you go out this way, they still account for different sizes. There's nothing hard to understand there. We can skip 36 because it's the same point as the other James Clark Ross one we talked about. 37, Lieutenant Charles Wilkes commanded the U.S. Navy. Okay, another argument from authority. And his journals also mention being consistently east of his reckoning. Something over 20 miles in less than 18 hours. That's because of magnetic declination, I would hazard a guess. Chris says if there was a force sucking things to the Earth, it's not. That's not how gravity works. As we fly through the galaxy at 500,000 miles an hour, we wouldn't be able to move. Yes, we would. Again, you're talking about relative to space, not relative to the Earth. You and I and this cup and my hat, they all move relative to the Earth at the same speed as the Earth. Or the surface of it we're on. But whatever. To quote somebody else, the Earth is not a ball. No, they're just wrong. If they're going to be that lazy, so can I. 39. Practical distance measurements taken from the Australian Handbook, Almanac, Shippers, and Importers Directory. Whatever. That's not a peer-reviewed journal, just like the rest of these quotes. It doesn't make any good claims about anything. It just says that somebody made a mistake in their math. Cool. If you spin two balls in a vacuum, Flatfish says, one hollow and one solid, they have a different inertia and torque. Explaining how things fall in a vacuum has nothing to do with explaining the lack of torque for a globe. Can you link us to this experiment, please? I want to see the experiment so I can explain it to you, or you can show me that I'm wrong. Because I will gladly be wrong if I am. Because I have shown you, with experiment, how all of these different things work. Fish. Now it's your turn. I have been patient. You're allowed to keep trolling. I really don't care. I'm allowed to stop you from trolling on my channel also. Please keep that in mind. No link to it. Alright, then we don't have to worry about it being an actual thing. What's the name of it, by chance? Do you have that? How can the Earth spin at the equator faster than the speed of sound? Because it isn't. When you are on the equator, you are moving at the same speed of the equator. And so is all the air around you. You are effectively moving at zero. The same as the wind. Because again, if you look at the Earth, alright? The Earth is a globe here. The vacuum outside of it doesn't cause the atmosphere to spin independent of the heavier Earth underneath it because of gravity. The gravity that pulls from the very center point against all this mass also pulls on all of this atmosphere in exactly the same way. And again, out here, further and further, there is no atmosphere. So if this is spinning and this is setting on it, and there's nothing here to contradict it, it's going to spin with the Earth. Same way, if this were a record player, the turntable will spin and the record will spin with it. For the same reason that the air will not stop the record from spinning. Because compared to the record and the turntable, the tiny little bit of air on top of it is negligible and doesn't stop the record from spinning with the turntable. Do you understand yet? The atmosphere is kind of like that record. The atmosphere goes on the ball, and if the ball spins, the atmosphere stays with it. The atmosphere is very much like those blue lines. When the ball spins, the blue lines stay with it. I don't have anything rubbing against the atmosphere to cause it to move when it's spinning through space. It's the same as though it's spinning through air. The blue isn't affected by the vacuum of space out beyond the atmosphere. Same principle. So you're saying the air at the equator spins at 1,000 miles an hour too? No. I'm saying exactly like this. The blue line stays relative to the Earth because the blue line is like the atmosphere, and the air where my hand is like the vacuum of space. You see how it doesn't touch it? Do you understand how my hand, this hand over here, is not touching the globe? That's why the blue moves at the same speed, the atmosphere, the blue. And just for a matter of point here, the atmosphere on the Earth, the part that sticks to us is only about as thick as that blue line relative to the size of this thing. So yes, the space that exists way out here does not cause it to spin. Because there's not enough force from space, the vacuum, to cause it to spin. The air moves at the same speed as the ground under it. Which part of this do you not understand? When there's a tornado, when there's a hurricane, yes, the air spins. The air that's on the surface of the Earth, for the most part, stays stationary until the sun warms it or cools it and you get winds. Again, I don't understand what question you're asking. The atmosphere moves at roughly the same speed, give or take a few miles an hour based on local weather conditions, as the Earth itself. Carbon says, Rev, stop lying. Everyone knows the Earth is hollow. But not if it's flat, Carbon. Come on, come on. We're going to skip the couple points there because they're, again, the same thing. Let's talk about the flight routes. Let's talk about them. If the Earth was a ball and Antarctica was too cold to fly over, it's not. I mean, that's a good reason not to, if it's true, but it's not. The reason we don't fly over Antarctica, I think, has to do with international treaties, or generally, it's cheaper to follow this line here than it is to follow this line here, for some reason. You just don't understand. One spin for 24 hours, and that's how little that is. Yeah, it's not very much when the Earth is very large, and we move with it. Triax says the Earth is the shape of a butt. Yeah, it's peach-shaped. Now let's go to the anus. And how the atmosphere that sound travels through is going the same speed as the equator. Lol. But, I mean, basically, kinda. But because Earth because space, because gravity, air. How can the Earth be flat and hollow? It's like a stuffed crust pizza, but the stuffed crust is like air. So if the air and the Earth are spinning to the east at 1,000 miles per hour at the equator, how can sound that only travels at 760 miles an hour travel to the west? Because sound travels relative to the medium it is in. This is why when you're in a car, the people in the back seat don't get the Doppler effect when you speak. Same idea. Like Triax says, you can charter a private plane to fly over it, and there is a base there called the Scott Base. So, Pure Carbon says, hollow flat, it's fourth dimensional. Best explanation yet. The same way the universe can be infinite. Because the sound is already traveling at 1,000 miles an hour. Well, no, not exactly. The sound is based on the vibrations of the air pressure. So sound itself isn't actually traveling, but that's beyond the scope of this argument. 44, if Earth was the ball and Antarctica was too cold to fly over, then you shouldn't have these flight paths. But, you know, there apparently are these flight paths or something. So then we get out the Google Maps and show that's fucking dumb. Anyway, on a ball Earth, Johannesburg to Perth should be a straight shot over the Indian Ocean. On a flat Earth, I should be able to see this from here, from the ISS. Or just there to there. I should be able to see New Zealand, give or take, from the west coast of South America. And I should be able to do so in an airplane. Or a rocket way above the atmosphere. But the only way that happens is when you get far enough away. And in fact, maybe even not. I forget how much curve there is there. Yeah, Negatorx is right. That's like asking how you can reach the front of an airplane since you only walk 4 miles an hour and the plane is doing 500 miles an hour. Negatorx gets it. Pure Carbon says it's like a Tesseract hypercube. Well, in another way of speaking, that's exactly correct. But again, we're not talking about what shape the cube is in time. We're just talking in space. Flatfish says, and I'm going to check something here real quick because I might have to... Oh, we're only at like an hour and a half. We're good. A little more time I'm going to have to get off of here, though. Hopefully we'll get through at least half of these. Although, the comments seem like a lot more fun, so we'll just keep them coming. Why does gravity overcome differing centrifugal forces from differing latitudes, while a butterfly never notices a thing fluttering around it? Well, you see this right here, Flatfish. The center of Antarctica, the South Pole, is equally far from the center of the Earth as the equator. Okay? That's why. It's not overcoming it at all. That's just how gravity works. Again, discussing the intricacies of gravity is well outside the scope of this article. And just to be clear, we're looking at, you know, so we'll go on to point 46. On a ball Earth, these 2 points should be a straight shot over the Atlantic. But instead, every flight goes to connecting locations in the Northern Hemisphere first. Because it's round, just like it shows, and it's basically a straight line on a circle. Also, it might just make more sense for customs. Humans do that kind of shit, you know? We have paperwork and bureaucracy. Humans aren't always logical when it comes to that shit. Put an airplane is a closed environment. Earth is an open environment. No, it's not. I've explained this to you 15 times. The space outside of Earth's atmosphere does not spin the Earth's atmosphere because it's a vacuum. In exactly the same way, the air that sits over a record player doesn't turn the record that's on the turntable independently of the turntable. It's the same thing. Spinning east-west is not north-south, so different latitudes have differing centrifugal forces. Right. I didn't say they don't. They're not enough different for us to have to worry about gravity on them. Because if you'll notice, whenever you stand upright, you see how these Arctic bears are standing upright? You see how the penguins are basically standing upright? You see how their ankles don't have to bend towards the equator to stand straight up. That's because gravity pulls straight down, basically, on them, rather than pulling toward the equator or pulling toward the center of a flat Earth. Earth is an open environment, yes, but the atmosphere is not generally affected by the vacuum of space because it's a vacuum. If you can't understand this, I can't help you. The atmosphere we have doesn't spin with space because there's no friction from a vacuum. You see. The Earth spinning below it, there's plenty of friction to cause that air to move with it. But the vacuum here, there's not enough force to cause the atmosphere to move with the vacuum instead of the Earth. Do me a favor real quick. Take and push your hand over your mouse pad if you have one. And notice how your hand does absolutely nothing to cause the mouse pad to move. The mouse pad stays in place where the table is, and your hand just glides over it, or your mouse does. More to the point, your mouse is like the vacuum of space. It doesn't move the mouse pad. You see. But Chris, I think you're just trolling us, perhaps. Go ahead real quick, take your mouse, move it over your mouse pad, and pretend your mouse is space. Pretend your table is the Earth. The mouse pad is the atmosphere. Why doesn't your mouse cause the mouse pad to move with the mouse? It's the same reason the vacuum of space doesn't cause the atmosphere to move, but the Earth causes the atmosphere to stay with it. That's an excellent example. We can do it again. I did it with the record player. What other example would you like? Because you haven't given one at all. Point 49. If Earth were a spinning ball heated by a sun, which it is, 93 million miles away, give or take, it would be impossible to have simultaneously sweltering summers in Africa, while just a few thousand miles away, bone-chilling frozen Arctic and Arctic winters, experiencing little to no heat from the sun whatsoever. Again, wrong. Angle of incidence and albedo explain why weather happens. 50. If the Earth were truly a globe, the Arctic and Arctic polar regions... The Arctic and Antarctic polar regions and areas of comparable latitude north and south of the equator should share similar conditions and characteristics, such as comparable temperatures, seasonal change, length of daylight, etc. Right, if they're comprised of the same thing. If you'll notice, this area right here is quite a bit different from this area right here. But this area and this area are both about the same. And that's why they both have big-ass glaciers that make up most of their land mass. So, Antarctica is by far the coldest place on Earth. Right. There's less land on Antarctica than there is in the Arctic. Because the Arctic has a lot more actual land on it to sink more heat into. Down at the south, it's mostly ice. So it reflects quite a bit more light. And up in the north here, where there's actually more land, it preserves a lot more of that heat. Because the ground absorbs it and generates it up through the ground. Water is a really good insulator compared to the ground, which gets heat from the center of the earth. The water will dissipate it much quicker, and then the water turns white when it freezes. Iceland versus Canada or England, again, you're looking right here in this circle, which has been edited for some reason. But up there, it's all frozen. And then this yellow one is the very temperate or tropical region, basically. All the way down to here is your subtropics as you get in toward Florida and everything. Right. That's not exactly correct, though, because the Earth is tilted. Those should be more like figure eights. But they'll overlap. They won't be exact. At places of comparable latitude north and south, the sun behaves very differently than it would on a spinning ball. No, it doesn't. It's just wrong. Here we show exactly how this works because the Earth is tilted. At different times of year, the sun is at different points in the sky. It's just how it works. Yep, same thing here. This isn't actually different times of day, though. This is different times of year. But, you know, whatever. If you're at the right place on Earth, it will look like that. The sun's rays do not come straight on. The Earth is tilted about that much. So the sun's rays don't come straight at it like that, ever. Let's just talk about the pictures. Again, same thing. If you're at the right place on Earth, you will see this sometimes in the year. 60. Anyone can prove the sea horizon perfectly straight and the entire Earth perfectly flat using nothing more than a level, tripods, and a wooden plank. Only if you have a wooden plank about 6,000 miles long. Which you don't. Right. This describes exactly what we can see. I wonder if I can find that video. Let's see. The video of that night flight from Vimeo, I think it was. I don't remember. I don't remember where it went. It doesn't really matter. I wish I would have kept it, though. It's fine. We've got a wonderful comment section going on right now. I kind of spaced out there for a second. But yeah, we have calculated it. You have given us absolutely no reason why it cannot be calculated. Fish. You have provided absolutely no evidence that anything I've said is incorrect. If you are unable to do so, if you are unable to tell us what kind of flat Earth it is, you said you have nothing to prove here, Fish. Do I need to go back and show you that comment? So what are you trying to prove, Fish? Can you tell me why the centrifugal force cannot be calculated? Can you give us the experiment you keep referencing in relation to the hollow versus solid spheres? Flatfish says, do it again, your math is dodgy. No, Fish. You do the math and show us why it's wrong. I'm curious, Fish. Which part is wrong? Can you demonstrate it or not? If you're just going to come here and shitpost, I'm going to time you out again. If you're going to argue the math is wrong, you have to show which part. Can you do so or not? If your next post does not contain... Alright, it doesn't. That's fine. You are now banned. Sorry, bro. You were given multiple chances to explain what you were saying, and you refused to do so. You came here to shitpost. I'm not having it on my stream. Take it to Twitter. Just, I don't care. If you want to have a discussion about this, that's fine. If you're going to sit here and say we're wrong without telling us why, then you can go eat a budgie, whatever that is. I honestly don't know. Maybe Triax can tell me what a budgie is. Because Flatfish said he would eat mine if he couldn't prove whatever he was saying. So, you know. Trolls are great. They're a lot of fun, then they get annoying. Very, very annoying. Alright, let's go on to, is there any other original argument here in this entire thing? This one looks different. Oh, there we go. See, this one right here explains exactly what I was talking about. The higher away you get, the wider the horizon goes, and why it still looks flat. A bird. A bird, alright. A budgie is a bird. Pure Carbon says, poor fish. He's been doing this the whole time. He's basically just shitposting. I want to try to have a real conversation, even though it's flat Earth and there's no real conversation being had. Here's a whole fucking, I don't even know how many pages this is because he doesn't know how to number them. There's no page numbers here. How many pages long is this damn thing? 35. And we're 14 of them through, I guess. 13 of 35 pages. So we're talking more about atmospheric lensing and shit. These buildings are 60 miles away in this image. If here's the ball, the ground base of the buildings would be several feet below the horizon. It's possible because of atmospheric lensing, or it's just really clever Photoshop. I don't know where the photo comes from. Nothing's cited. 75. Let's see. From Italy at a height of just 70 feet above sea level, the island of Corsica can often be seen. Good. So why can't I see things that are, 1,000 miles away? You're telling me these things can be seen. Go for more than just the edge of what you can see. If you raise yourself up a little bit, you can double your horizon. I think it was XKCD that had a good one on that one. But yeah, it's possible to see the horizon from further away than what you'd originally think, just based on that. If you double your height away from it, the horizon changes enough that you can see significantly farther away. So you go up 500 foot on a mountain or 1,000 foot, you can see much farther than you normally would be able to. Possibly 2, 3, 4, 5 times what your horizon is at 3, 4, 5, 6 foot. Someone who has an unpronounceable name says, Flurfers are clinical mongoloids. Well, there's no reason to call them names. Shitposter is one thing, but mongoloid? Ah, man. Trust me, mate, all their arguments have been debunked, especially the one you're looking at. Bedford-level experiment was debunked years later. Yeah, Cody also did one on it from Cody's lab. I just thought this was a fun piece of thing to go through. But then there's like 7 points in a row that are just the same thing again. All these things are further from each other. How do we see them? I like how the 24 miles is greatly exaggerated here. But at least they get the basic idea. But if you go up to the top of their sails according to this, I should be able to see, like, way over here. Whereas with this, I should only be able to see, like, you know, anywhere. Oops. Hey, let's take a look at the star that happens to be in the center when we're looking up from somewhere. Cool, man. So we got more star stuff. We don't have any new points here. Here's a railway with a vanishing point, because perspective in a drawing is our clearest view. Oh my. Well, I mean, to be fair, he did say he'd eat my budgie if he got timed out again, and I just blocked him, so actually he doesn't have to do that, I guess. 110, Magellan and others east-west circumnavigations are quoted as proof of the ball model. I don't understand why there's a malformed penis on my screen, but there it is. Nice latex hat, by the way. This is actually leather. You can't see that. That's all leather. Maybe if I put some light inside of it, I don't fucking know. How does science work? Yeah, you can't really see it. It does kind of look like plastic, I guess. Yeah, I'm not going to send you my hat for GIMP work, though. I apologize. The hat is mine. It must stay on my head. Hey, guys. Gravity is a lie. Did this picture make any of you change your mind? Did it? I'm curious. Hey, I can turn a photo upside down because gravity is magic. This is just getting to shitposting itself, isn't it? Newton also theorized, you mean hypothesized, because words are important. By all right, I should see France from where I live, says Triax, but I don't because of curvature and Polaris is not exactly center. The unpronounceable fellow. I need something to call you. I'm going to call you K, I guess. Coin something? Okay, coin. That's you. Latex is a form of rubber. That's true. That's why I said it. I mean, latex is like rubber plastic, I guess, but whatever. Vinyl is plastic. So yeah, latex is rubber. The Earth and the Moon, alright, they have arrows that come out of them. And that proves that the Earth has more arrows than the Moon. This is grade A graphics right here. Right here. He says he does not own a leather GIMP suit. Oh, well. By the way, this channel is advertiser friendly. In case I need to say that. This segment brought to you by Sargento Cheese. Now selling cheese balls in honor of the ball Earth. Not really. They're not sponsoring me at all, but I'm hoping they'll block me like they did with Rusty Cage. That'd be great. Triax has one he can lend you. If you two are in the same continent, you can get together someday. And since the Earth is flat, you can just walk there, right? I could call you God, but that's me, so I don't know. I feel like I'm talking to myself. You see. Moon, Sun appear almost same size. They do when you open up Photoshop and make them look the same. The Sun is clearly not 93 million miles away because of this shitty photograph. So, all right, here's another fun one for you. If you want to have fun with a flat earther, when they come and tell you, well, look at the way all these rays are going, tell them they're actually all flat because they're actually just heading toward one of these vanishing points. They're actually parallel. They just look like they're going together. And then see how upset they get. Just a little bit of fun you can have. Essential parallel sun rays. Well, I mean, you've got the parallel rays, But you got to remember, the ones coming from the center of the Earth, also, or center of the sun, rather, are also going to hit up here, and the ones from the edge of the sun are also going to hit down here. But if you wanted to see those, what the fuck are those called? What are those called? Sun rays back to their, oh, what are those called? Perpendicular. ISS had a few good photos of that. Images, I'm sure they're here somewhere. Maybe I can get them from the ISS. I forget what they're called, dang it. Like this. Yeah, that's it. That's fine. Oh, this is actually on the Reddit page. That's fucking sweet. I wanted that fucking image, though. View the image. There we go. So yeah, you get the basic idea. We can... Oh, it doesn't like that. It's better. But no, when you view them from above, they actually are flat, straight, perpendicular. That's all I was trying to say. I don't know what I have to do here. Reset. 12. There we are. That's better. So yeah, they actually are perpendicular. They just converge. Just thought I'd show that. This is when the sun is directly behind that cloud. So they're all coming at you from all four sides. You know, the Flurf charlatans from Globebusters are also streaming live right now. Want to know how many viewers they brought? I can only imagine. I don't even know how many viewers I have right now. I don't really pay attention to that stuff. Maybe I should. Then I could be the best one ever. Ooh, I got 47 playbacks. Average live duration of 18 minutes with a total view time of 15 hours. That's impressive. That's pretty good for just sitting here and talking about this thing. Globebusters, man. I've watched a few of the Flat Earth guys, but I don't really get involved with it much. I figured I'd do this, though, just because. Just because. And here we have more stuff that doesn't really seem like it fits in a scientific paper. Number 136. Yeah, we'll just jump right ahead. Many people think that modern astronomy's ability to accurately predict lunar and solar eclipses is a result and proof positive of the heliocentric theory of the universe. Big sentences for not saying anything. Pure Carbon, 1,000 viewers. That would be nice. I'm not Telltale Atheist, though. I can't just magically get 3,000 people. He's done pretty good work, though. Y'all should go watch him. He's really cool. The fact of the matter, however, is that eclipses have been accurately predicted by cultures worldwide for thousands of years before the heliocentric ball Earth. Yeah, and it doesn't prove anything. Just proves people got really good at predicting something based on faulty logic. You can do that. Coriolis effect is often said to cause sinks and toilet bowls to drain spinning in one direction and the other. That's actually just the way they're generally built, though. Part of it's Coriolis, most of it's just the toilets built in Australia. For some reason, the water spins the other way, because they build the jets the other direction. $143. People claim that if the Earth were flat, with the sun circling over and around us, we should be able to see the sun from everywhere all over the Earth. We should. Absolutely we should. There's no reason we shouldn't. There's no atmosphere to get in the way. Northern Hemisphere, Southern Hemisphere. Right. The moon looks upside down. Because you have Photoshop. Aren't you proud of yourself? That one is actually just a well-known piece of horseshit. It's not even upside down. You only tilted it a quarter. Come on, man. It's the same picture, even. Like, it's got the same pixels and everything. Same phase, same day, same lighting, same composure. I like how the light source is still on this side, though. And still here, just like they flipped it. It's great. Your god is fiat currency. Give me all the currency. I want the money, man. I mean, I want, like, world peace, and I want people to realize the Earth is a globe. But money is nice, too. Talk about Felix Baumgartner again. They can't get enough of him. Right, this explains to you how the Earth spins, and how it really doesn't affect you very much. Here we have somebody saying oh, that's cute. Somebody doesn't understand how a GoPro is. You could have just taken a picture when his head was level, but you didn't. Oh well, lens corrector. Oh, that's quaint. Yeah, it's not going to be that much because of fisheye. It may still be pretty flat at only so many miles up. Through a telescope, you can see something that looks like this synced with the ISS tracker website, claiming to be the ISS. With a better telescope, you can actually take a picture of it. All artist impressions. Oh, okay. Well, we can fix that. The ISS images. This one is not an artist impression. That one's an actual picture. There's a picture of it. Upside down. There's a pretty cool picture of it. That one might be a painting, but it appears to be a picture. There, that one's an artist's conception. That one's the ISS. So yeah, we got plenty of pictures of the ISS. Clinical mongoloids. How is that any different from regular ones that are not diagnosed? How big is America? Cool. Now we're talking about how it's covered up. Monkey balls. All right. All the rest of this is just crap. Oh, hey. They're triangles and shit, man. It's masons. Oblate spheroids. Yeah, they look like that. Sometimes they're a lot less severe. So anyway, that's going to be about the end of that, I guess. Earth is flat with some graffiti. That makes it true, absolutely. Now we've got the ship sailing off the edge, even though the edge is supposed to be frozen. The stream is just about over. So, I guess if you enjoyed that, give it a thumbs up or whatever. If you didn't, give it a thumbs down. Leave me a comment down in the comments after this thing renders if you feel like it. And maybe we'll talk more Flat Earth next Sunday. That could be a lot of fun. I'm sure it's Monday for some of you. So, with that in mind, this has been Reverend JR signing off. Thank you all for tuning in. And have a good day. And then I stopped being a potato and pushed the button.